Hello, I am Firyuza and you are watching Bold Science with Firyuza. I have already told you about the main equation obtained in general relativity, the Schwarzschild solution. The link to that video is in the upper right corner of the screen. Click it to go directly to the video. I also explained that this equation contains three fundamental errors, which we described in a paper published in a scientific journal together with Vasily Yanchilina. I also presented a report on this topic at the APS Global Physics Summit, which was held in Anaheim, California. These errors are also discussed in our books, which are sold in bookstores, including Amazon. Today I will examine the first error in more detail. Why does the main solution of general relativity, the Schwarzschild solution, contain the number 1 rather than some other number? And what one are we talking about? According to general relativity, gravity slows down the passage of time. Here, dt is the time interval that has passed at a large distance from the mass m, and d tau is the time interval that has passed at a distance r from the mass m. Did you find the number 1 in this equation? That is the very one we are about to discuss. What meaning does it carry? In general relativity, it is assumed that 1 represents the time scale in empty space at a very large distance from the mass m. This view was formed in the first quarter of the 20th century. At that time, astronomers mistakenly believed that distant galaxies were not giant clusters of stars but ordinary gas nebulae located within the Milky Way or nearby. Astronomers simply knew almost nothing about either the size of the universe or its mass. For example, the famous English astronomer James Jeans, in his article The New Outlook in Cosmology, claimed that the entire universe had a radius of about 4 million light-years and ended somewhere beyond the Andromeda Nebula. In considering the boundaries of the universe, Jeans relied on two fundamental arguments: Olber's paradox and the gravitational paradox. According to Olber's paradox, also known as the photometric paradox, if the universe were infinite and homogeneous, the night sky would shine with continuous light. The gravitational paradox states that an infinite collection of stars would produce an infinite gravitational field. Therefore, Jeans concluded that the universe must be finite and leaned toward the view that the observed objects, including the Andromeda Nebula, were already close to its boundaries. Here is an excerpt from Jeans' article showing how in the mid-1920s, photometric, gravitational, and other arguments were used to justify the idea of a comparatively small universe. It is now known that the universe is enormous. It is filled with galaxies, stars, dust, planets, asteroids. In other words, space is not empty at all, correct? Each individual object in the universe makes its own contribution to the time scale, which is proportional to its mass m sub e and inversely proportional to the distance r sub e to it. If we sum the contributions from all galaxies and other masses, we obtain a quantity that is approximately equal to 1. This is the very one in the Schwarzschild solution whose origin is hardly discussed in modern science. Richard Feynman called such a coincidence one of the greatest mysteries of nature and concluded that the use of number 1 in the Schwarzschild solution as a constant is a mistake, since in essence this 1 represents the contribution of all the galaxies and stars in the universe. He wrote about this in his lectures on gravitation. We open lecture 5.3, Cosmological Effects of the Time Dilation, Mach's principle, and we read: another possibility is that the 1 which appears in the formula of time dilation, is a mistake in thought. We have written a formula which applies only when the potential differences phi are much smaller than 1, so that the constant 1 may somehow represent a normalized contribution of faraway nebulae. It is important to understand in different regions of the universe time flows differently. For example, on Mars, the frequency of atomic radiation and therefore the rate at which time passes would differ from that on Earth. But if there were astronomers living on Mars, they would suspect nothing. They would simply take their own time scale as the unit. Astronomers in another galaxy would do exactly the same. Everyone takes their own time scale as unity. There is no other way. We use the time scale in near-Earth space as a unit not because it is special, but because it's ours. Now I think you understand the meaning of this equality. It is precisely the contribution of all the matter in the universe that creates that very unity in the time equation. Let me emphasize, the one is the result of the influence of all the masses in the universe, not something abstract and predefined. This means that the unity carries a deep physical meaning. Thus, the unity in the Schwarzschild solution is not an abstract constant and not empty space, but the result of the combined influence of all the matter in the universe. It has a specific physical origin and sets the time scale in our region of space. In the next video, we'll examine the second error in the Schwarzschild solution, and then the third. After that, I will show how all three problems can be resolved simply and logically. But be prepared. This will inevitably lead to a revision of the familiar consequences of general relativity and to a more consistent and coherent picture of the structure of the universe. You've been watching Bold Science with Firyuza. Subscribe, give the video a like. Let's continue exploring the foundations of science.